Great. So welcome, everybody. I'm Daniel Homola. I am AI engineer at BMW Research, currently leading a project of in-car graphical user interface agent, as already mentioned. But now, before I dive in, I would like to just get a quick sense of the room. Please raise your hand if you know what a GUI agent is, or maybe you've heard the term computer use agent. So, okay. And I would like to also raise your hand if you've built such an agent before. Okay, that's great. So I hope the people who didn't raise the hand learn something from this talk. And basically, it's not about if you've built one before or not. Whatever the solution is, it's about us building systems, agents, models to provide value to the user, right? It's not about the solution. And I would like today to tell you what is the role of GUI agents in this game, and why do we care? Why should we care about also GUI agents as a potential solution? So today we will dive into that question, and I will also share some of the insights from building such an end-to-end system with my team in the past few months. Maybe you would be asking, okay, why a guy from BMW is talking about this? So you can see on this slide the interface of current Neue Klasse. Basically, it's the interface for the driver-vehicle interaction. And you see multiple displays. And this is also where we can provide the value, right? So we have the panorama display, we have the central display, and then basically this is where we can provide the value, but not only through the screens, but also there is the digital companion. I have a short video for you. So as you could see, there was digital companion on board to make your drive smarter. So what does it mean, make your drive smarter? It's a bit vague, right? But this is why we are here at AI Engineering Conference, and agents are the hype, and we can use agents to create the smarter assistant in the future. And in BMW, it's so-called intelligent personal assistant. So why agents, why now? I guess this is something which I don't have to explain in 2025, why agents are relevant, but why GUI agents are relevant. We will touch that topic today. And also, basically, why should we care about interfacing many services also with GUI agent? Because customers care about ecosystems and having a lot of services integrated in the same ecosystem. And we, as big companies, we have to integrate many services, and GUI agent can be a solution that can help us in this. And then suddenly, the agents can also treat the application user interfaces as APIs. We don't have to integrate all of the APIs. And you can imagine use cases like buying groceries, booking accommodation, buying tickets for cinema, whatever comes to your mind. And then we basically have the simple user utterance, and then we can do an action. It's not just the chatbot, it's actually doing work and providing value for us by doing action on our behalf. So today we will briefly mention how we can build these agents. There are two ways. The API first, this is every talk you mention, you see MCP servers here and there, and most of the times it's API tools. But today we will touch also the GUI first option. And let's start with the API agents, API tools. You most probably build already this LLM picks a tool. This tool has a connection to an API. You compose the calls, you return the response, and then you can answer something to the user. This is great for stable and well-documented APIs, but it has also certain limitations. Many times there are applications that have no APIs. The APIs are not good quality. They are not even endpoints for the things that you want to do with your agent. Also, the execution is mostly hidden, so you have to come up with a way, how do I inform the user and the client that I'm doing something? So this is the limitation that we have to do. And also the APIs are sometimes spaced, so I believe there you can also somehow go around it if you need to. Then we come with the GUI agent. Why is it relevant? We heard the limitations of the API agent. So we are operating instead of the functions in the API, we can rather use the graphical user interface, and it's very highly adaptable. So we can generalize to many applications, many services just by reading the user interface application tree, or the pixels, or you can use both. It's your decision. What do you need for your use case? And then you can basically type or send a tap like a person. And you don't have to just limit yourself or like click something on the top right corner. You can really do like long horizon tasks, complex tasks, which need a lot of actions. So it's also the decision making and the reasoning behind the models nowadays in the foundation models that are focused on GUI agents can also do that nowadays. And basically the added value is also the navigation is also flowing visually. So you as a user, you see what is happening, and it's also like human machine collaboration with the agent. So you see what is happening, and the agent can even narrate whatever it's doing. Then you can interrupt, then you can do whatever you want. And then this is also a more intuitive user experience. But it also comes with limits and challenges. So the maintainability, security and safety, and the efficiency of such an agent, you can imagine that it's not a simple task to put something like this into production. And maintainability, I mean, if the design of the application completely changes, then you have to have, I believe, evals would help you to go forward and see if it still works in the scenarios that you care about. And maybe in an API, if the design changed, you don't have to change anything in the API tool. So this is the change that you need to care, and also the security, so that your agent, GUI agent, doesn't do stuff that you don't want him to do. And also you need to do confirmations or having basically scopes where the agent can operate. And also the efficiency, sometimes maybe you, with an API tool, you can do it in 2 calls, but for GUI agent, you need like trajectory of 7 actions. So this could be also sometimes like you have to see which use case makes actually sense to apply with a GUI agent. But where I would like to come is basically we have these 2 paradigms, and it's not about one or the other. Let's start with the paradigm of API agents. There's one great paper, API agents versus GUI agents. It was recently released in June 2026, and basically it gives you kind of like advice which paradigm makes more sense. API agents, as I already mentioned, stable, well-documented API, that's great. But then GUI agent, that could be great if you have a legacy software, doesn't have an API, and there are many, many different other situations where you would probably opt for GUI agent. But what I want to tell you here, that it's not about one or the other, it's about building a hybrid system that can eventually do both. So then you can be future-proof and scale integration of many services without needing to integrate hundreds of APIs worldwide. So this is where I would like to get, and this is basically the advice that I would like to also share here, that I think the path is going hybrid, that if we want to integrate many services, we can integrate the most important, the most secure way for the API tools, for the services that a lot of people use, but then we can cover many, many more apps and services with a GUI agent. And then basically we have a voice and orchestrator as the glue between these two. But now I would like to move on to the insights that we learned during our build of building this in the past few months, our MVP in research. So I want to be clear here, like it's a research MVP, it's not something that is in production. It's something that we can showcase to stakeholders internally in a car, and we can run it as an end product in the test car. So this is what I would like to show, and we have the same brain, so basically the same agent, but 2 runtimes, 2 tracks. So to build faster and create like a very quick prototype, you can use Android debug bridge, for example, because we are using Android as an ecosystem. So that gives us very quick iteration. And then you can just have, for example, a Python-only agent that basically has the executor and also does the logic. And then you can build your own framework, or there are already existing frameworks that can simplify this for you. For example, Mobile Agent v3, it's from Alibaba, recently released paper. I'll come to that as well. Or DroidRun, that's a European startup that also has a same name of the framework which you can use for a quick prototype. But making it a product, you want to run it, for example, in an Android device, and then you don't want to have a plugged-in developer laptop. You want to have a real product, so that's where we have an Android application which uses Accessibility Service API from Android to do the clicks, to do the keyboard input, and basically we are then talking to our API remotely, or you can have even like your local small model, which we will get to as well. But it has also caveats. This is also slowing you down, because then as a user app, for example, in Android, you cannot do certain events, and then you have to somehow find ways around this kind of limitation that you have, which you wouldn't have in this ADB, Android debug bridge. the practical insights that worked for us. It's basically starting atomic. So what that means is like start with just like, am I able to click our icons in our interface? Like, what is the resolution which I need for being able to execute on our screens? So these kind of actions, just testing multiple models, which works for us, which works for our interface. Then evaluation, also having like kind of building up slowly your evaluation framework. So starting like atomic, so again, click that button, but then also top down, like having like complex task, add these 5 items into the cart, and that's suddenly becoming more complex task, and then you can evaluate the whole agent end to end. Also the point of the executor, so hardening the executor, that means like making it as deterministic as possible so that you can rely on it, because you know, like relying on just the LLM, that will not put you far. So with the executor, I mean, you can, for example, save some of the actions that if you put keyboard input, then you can automatically press enter. You don't have to like do another action, do another inference. You can make it smarter, faster, and more deterministic, and have certain fallbacks to make it more robust. And then you can also plan in chunks, so you can generate multiple actions at a time. You don't have to always, every step, generate the action. You can just compose multiple actions and save yourself with generating multiple actions every time. And then also what helped us is building observability for our GUI agent, because many times you would not know why it failed. So then with the observability, you can then quickly see, like, was the, for example, image already rendered, or what are the timings there? And this really helped us to make quick progress. And for building voice mode for our quick MVP in a few months, we used eventually LiveKit to, it's like open source tools that I'm here sharing, that was a quick solution for us that we can self-host and basically provide a voice-first GUI agent. Another point which I would like to mention is also model choice. This is more in the research insights, that you can mix a specialized VLM with the tight executor, and you can do really well. You don't have to use the closed models. You can also go small, and this is also my advice if you want to build your GUI agent. Nowadays, like very recently released paper from Alibaba Mobile Agent v3, 7 billion parameter model is doing really well in the GUI agent task, so you can go small, and it's a foundation model optimized on Qwen 2.5 VL, which is a very good model in general for vision tasks. What I really find is like a piece of art from the paper, from the mobile agent paper, is the trajectory data pipeline that they created to self-improve the agent and the model. Basically, they generate the user queries, then they do the trajectories, they have the correct and incorrect trajectories, and they have a human in the loop for the incorrect trajectories. So then they can train with reinforcement fine-tuning the model and basically always improve, and only part is human in the loop is for the incorrect trajectories to give the reference trajectory. And this is really beautiful because like they can do large-scale training on these trajectories and really move fast. So even if you would like to improve on your trajectories, I believe you can learn from their approach. So the paper that I would like you to look into if you're interested in this topic is the mobile agent paper, the small language models paper, which you probably know from NVIDIA, and the paper with the comparative study, when to use which paradigm, API agents versus GUI agents. These are the 3 papers that I would personally recommend. And the 3 takeaways that I would like you to leave this talk with is basically the hybrid complementarity. It's not about, oh, let's build GUI agent instead of API tool. It's really being mindful when which solution makes sense and having the power of the both solutions in your system. And then basically your end-to-end workflow can be either API only, GUI only, or even the hybrid. So whenever maybe the API tool can do some parts, and then you can finalize the last action with your GUI agent. So what matters is also the deterministic execution, the evals, and observability. Because then I believe that these practices can then turn a cool demo into dependable behavior for the users, so that it can be there can be the trust and safety, and also for the developers, because then you can do faster debugging and you have measurable progress with the evals. So it's not about like just vibing. This is, I believe, very important to have proper evals in this GUI agent space.